Subscribe and hit the bell icon to never miss a video from Let Machine Talk. So this is part 2 of Pandas library, tutorial 5 of the series Python for data analysis. Last time in the last video I think we looked at this point of notebook, and then we are going to continue from box and whisker diagrams. So how to plot a box plot. This is the box plot basically. So it lets you know your data better in one diagram. You can know what is the median, what is the first quartile, third quartile, maximum, minimum, many statistical decisions, statistical modeling. It helps in many decision modelings and various other things as well. So this is box plot basically for a particular data, and to make it in Pandas we have the command data.boxplot, and we have to call it. So if we want to set up the figure size, then we have to use matplotlib. So plt.figure, and figure size you can give it 20 by 16. That's the size I use, but you are free to choose anything. Then this is like, and the plt.show, it lets you show the diagram. So basically if you don't do this, then it won't plot, and it will just be on the axis, and to show it you have to type plt.show. So we'll come to that later. It's a part of matplotlib. So in the Pandas, this is the data frame what we were working on, if you remember, data, and I'll call it just data.boxplot, and you can see all the columns in that table in the data frame. We have the box plot for all of them simultaneously. If you want to make for a particular column, then you can do that as well. Just type here some column name and then box plot and just call it. So you can have this. Now how to dot histograms. So histograms is basically you have to see the frequency distribution, the kind of frequency distribution what the data offers from each column. So you can do that data.hist. It will plot all the possible histograms of all the columns which are numerical in data type. And then what information we can get from this histogram. Basically most number of houses in this data contains 6 rooms. So this is basically the histogram for number of rooms, and you can see that at 6, almost 6 or 6.5, something like that, you will have like maximum rooms popping up, maximum, so it's more than 100. And there are more number of houses away from Charles River in this data set. So from this you can know, because the houses near to Charles River, they are spotted as 1, and away from Charles River are spotted 0. So the number of zeros are more. So therefore the Charles River away, number of houses away from Charles River in this data set is like more than number of houses near Charles River. And then most houses are at weighted mean distance of 2-3 miles from Boston Employment Center. So this is the column that represents. So it's like 2 to 3 in between, somewhere 3 I guess mostly. So most of the houses are in this space. And then what are we unsure about? For example, crime distribution, for example. So crime distribution, we are not getting a lot of information from this, so we have to zoom it a bit. So we'll create bins. So bins can be used to go more granular, like if you want to zoom into a particular section. This example I zoomed into the range of 0-15, and which was not exactly interpretable in above histogram. So you can see there is nothing you can get from this. So to zoom it, you'll have to pass bins here, and then once you pass the bins, and you have to use the command range. If you haven't seen what range does, you can see in my previous tutorial of Python basics, and it's in part 1 or part 2 I guess. I'll put the recording. And if I have to see like so I'll go in more granular, and in an interval of 1. So 0-15 I'm choosing the range, and in a step of 1 I have to go granular. So I'll do this, and I'll have this plot. So now this is more clear. So close to 212 houses in this data set which are in area where crime rate is less than 1. So crime rate here, so it's less than 1. So this data set, it has something like this. So if you want to zoom in, you can use bins. Then it's just some random plots. So data.plot, if you have to plot it against an index, any index, what the index is there. If it's an ID, that it will plot it against the ID. If you want to set your own index, suppose you have a date column, and if you want to set it as index, so you can use data.index and that particular column. So it will set the index to that particular column, and then you can plot this. Then you can use the data.plot, then specify the figure size inside that, and plt.show, it will plot all the columns against that particular index. So this is kind of messy, so a lot of mess isn't it? Let's sort it out. And I'll define one plot function here, define plot, and then I'll plot each column separately, and then it's just a function for that. And if you don't know how to use map function, please check out part 2 of tutorial 4. So we'll use map function. I'll pass all the columns in this plot instead of x, and then it will plot it against the index whatever we have here. And this is all the like a crime rate plotted against index. Then this makes no sense, but you can always change index as you like. And then if you have to watch your memory usage, then data.memory usage will give out all the memory usage for each and every column, and so on and so forth. Then there is an aggregate function. Pass the function as this list. So basically whatever you want to aggregate with. So if I want to aggregate, data.agg is the command, and then I'll pass the function. So inbuilt function is like mean and sum. So if you want to know the mean and sum for all the columns, then you will pass the functions and then data.agg. If you want to know certain functions, like apply certain functions on certain columns, that also you can do. That pass it as a dictionary then. So specify the column name, and then opposite to the column name, you'll have the like key will be the column name and value will be the function, and as a list. So if I do this, then zoned, you can see this column, that only min and max function will be applied on this column, and then mean and sum will be applied on ID because we specified that way. And then we have data.group by crime rate. So we are trying to group the data by crime rate and by mean. So we'll call a function on mean, and then it will group by the mean. And so this is like this tidbits. If you want to use this, I haven't really used that much. And then if you want to set up the display options, then you can do the pd.options.display. So what happens is when you apply this, so you'll see this. If you have a lot of rows, then it will accommodate this. If in certain situations you want to see like what are the different, how many columns exactly, if you want to know. And if you can set the display, if you want to shorten the display, then you can set the display options to this as well. So if I'll do this, and then so you can see in this data frame you have a lot more columns displaying and lot more rows displaying. I set it the columns and the max rows to 10 and 5 respectively, and you can have it in this way. And a brief description if you want it. And then the scatter plot, you can plot the scatter between certain two columns. So if I want to plot between crime rate and the median price, this is the plot basically. So crime rate is like 0, between 0 and I don't know, we haven't set the bins yet. So this is just a demonstration. Then if you want to plot like Charles River and median price, then you can do that as well. Then data.plot.scatter between distance and crime rate. And then so you can do all kinds of plotting, and it basically depends all up to your tasks. And you can use seaborn for scatter plot. That's much more effective because you have to specify every time, you have to specify the names here. And so the seaborn, in my opinion, is much more like systematic and beautiful and easy to use library for visualization. So if I just do like sns.pairplot and just data and plt.show, it will display, it will make all the possible like a matrix of all the possible scatter plots, and the diagonal, on the diagonal positions all will be the histograms of that particular column. So it is really useful in that sense. We'll look into the seaborn later, because it has like wilding plots and several other things which are much more like better for visualization purpose. We can go on into that later. If you want to check out this repository, I'll put the link in the description below. It's on my GitHub, so you can clone it from there. I'll push so see you in the next video. Please like, comment, share and subscribe. Thanks for watching.